Welcome to Investigating Myself, a side series of 3-minute lesson. I sequenced my genome. Let's see what it has to say. Today's topic, BRCA. There are recorded cases and treatments of breast cancer dating back to ancient Egypt. It was apparent that some cancers ran in families, like a genetic disease resulting in very early breast and ovarian cancer. Beginning at around 1990, scientists investigated these families with high breast and ovarian cancer rates to find the exact genetic cause. Theoretically, the family members with breast or ovarian cancer all inherited the genetic cause. So by comparing many individuals and seeing what DNA they have in common, you can narrow down to where in the human genome the causal site is. This is called linkage analysis. Over the years, the search narrowed down to 2 genes, breast cancer type 1 and 2 susceptibility protein, BRCA1 and 2, BRCA1 and 2. Inheriting mutations in just one copy of either can result in a 5 times greater risk of developing breast or ovarian cancer. BRCA mutations can lead to other cancers as well. BRCA1 and 2 are unrelated genes on separate chromosomes, but both are tumor suppressors. Humans have many tumor suppressor pathways, but BRCA1 and 2 are highly active in breast tissue. They help repair damaged DNA or demand a cell kill itself if beyond repair. We have 2 copies of each BRCA1 or 2 gene. Inheriting an intrinsically defunct copy of, say, BRCA1 greatly limits tumor suppression capabilities. Furthermore, if the remaining good copy is later mutated by something like UV, there is even less tumor suppression. We traditionally think of BRCA1 or 2 mutations occurring only in Ashkenazi Jewish populations, but there are many, many more affected populations, including French Canadian, Swedish, and Pakistani. These populations often have completely independent mutations that inactivate BRCA1 or 2. As a result, health and ancestry tests cannot and do not test all of these. 23andMe, for example, only tests 3 BRCA1 and 2 mutations, those most common in Ashkenazi Jewish populations. Testing negative for those does not mean you are off the hook. You could have other BRCA mutations, but somewhere else. If breast or ovarian cancer runs in your family, a genetic counselor can provide broader genetic tests. You would probably not need to sequence your whole genome to find it. But my whole genome sequencing does not reveal any pathological BRCA1 or 2 mutations. However, this does not mean I could never get breast or ovarian cancer. It can still happen sporadically. This has been me investigating myself. See you next week. If you like 3-Minute Lesson or Investigating Myself, rate and review if you so choose. 3-Minute Lesson is a member of Podbreed.